Please let these notes serve as a review before you do your retake. Okay, so here we have a chemical equation, and we have a given K value right here. We have a given K value of 12.50. Just completely made up by me, so you just bear with me. And we need to calculate K for the synthesis of 14 moles of nitrogen dioxide. So the first thing you want to do is that you need to remember that when I ask you for a K and you're given a K, or I ask you a KP and you're given a KP, you're asking yourself two questions every time: forward or reverse. So what do I need to do to make this the condition of that reaction? So if you keep it forward, you just keep your value of K. If you reverse it, you have to put your K underneath 1. Okay, so that's the first question. The second question, you say multiply by what? If you multiply something by a factor of K, you will then take K to that power. So if I K to the n. So if I multiplied by 2, if I multiply my chemical equation by 2, then I raise K to the second power. Multiplied by a half, I would take K to the half power. So let's go back in and look at this problem. So we know that we're going to synthesize. Synthesize, remember, means makes. Produces, creates. I'm going to synthesize nitrogen oxide. So in this chemical equation, I am not synthesizing, I am decomposing. So in order to synthesize, remember, means makes, I'm going to need to reverse the reaction. Okay, so I took care of that part, the descriptor word there. Now I want to make 14 moles of what? Nitrogen oxide. So I look up here and I say I only have 2 moles of nitrogen oxide. So to get 14, I have to multiply by 7. So because I reversed it, I have to put my K underneath 1. And because I multiplied by 7, I have to raise my K to the 7th power. Remember that this raised part needs to be underneath the 1. So on my calculator, I'm going to take 12.50 caret to the 7th power, or some of you might have a y to the x key. And then I'm going to hit my reciprocal key, or my inverse key, 1 over x key, or x to the minus 1 key. And then I just need to put my calculator in scientific mode. And I get here 2.097 times 10 to the negative 8th for my K. Okay, part B. Decompose. Decompose means breaks down. So I need to see, does this reaction up here describe my chemical it's asking about, nitrogen oxide, breaking down? It does. So I will keep my reaction forward. Now I need to evaluate the numeric. I want 1 mole of nitrogen oxide. I have 2. So what times 2 gets me down to my 1? I'm going to multiply by a half. So because I kept it forward, I do not put it underneath 1. I just keep it as K. But I did multiply by a half, so I have to raise it to the half power. So on your calculators, you're going to put 12.50 caret 0.5, or 1 divided by 2. If you're going to do 1 divided by 2, you'll probably want to put either the number in parentheses or the power in parentheses. I would mess with your calculators to remind yourselves how to do that. So I get here my K to be 3.5355. So it'd be 3.535. Okay, continuing. I would double check, use your calculator, make sure you can get both my answers using your calculator correctly. If you're having issues, you can conference with me or email and I'll try to help you. Okay, next problem. Here we have a chemical equation for which we are given a K value. It says calculate the K for the formation of 1 mole. So we're given a K and we're asked for a K. So we're thinking about formation of 1 mole here. So we're going to think about our 2 questions. Am I going to forward or reverse? So I'm going to form. Form means makes. I need to form what? I need to show that it's forming, or write a K, calculate a K, for the formation of NH3. So this does not show NH3 being formed, so I need to reverse it. And then I need 1 mole, and I have 4, so I'm going to multiply by a fourth. So because it's reversed, I'm going to put my K underneath 1. And because it's to the 4th power, I have to raise it to the 1/4 power. Remember that you're going to do this part first and then put it under 1. So here's how I would do it on my calculator, pardon me. 1.25 to the 5th negative caret 1/4. Remember, you may have to use a set of parentheses or a double set depending on your calculator. And then I'm going to take the reciprocal or the inverse by hitting the inverse key. And I'm going to get, and my other set of notes talks about those keys. You might look at those notes. 16.82. 16.82. Okay, continuing on to the next example. Here we have formation of 8 moles of NO. So again, we're thinking about formation. What does that mean? Formation means makes. I'm forming NO. This does show NO being formed, so I'm going to keep it forward. I need 8 NOs. I only have 4, so to get to 8, I have to multiply. I always think about multiply by 2. Because it's forward, I do not put underneath 1. I'm just going to take 1.25 times 10 to the negative 5th, and I'm going to raise that or square it in this case. So on my calculator, I'm going to take 1.25 to the 5th negative, caret 2, and I get 1.563 times 10 to the negative 10th. Okay, next example. It says reaction of 10 moles. So I'm thinking about the reaction. So reaction of what? The reaction of NO. This is not showing NO reacting. Reacting means that it's going to be a reactant. So I'm going to have to reverse this. I need 10 moles of what? 10 moles of NO. I have 4. So I have to think about what times 4 gets me to 10. So that should be 5/2. So then I'm going to take, and I reverse it, so that means K has to be underneath. And I multiplied by 5/2 to get me to 10, so I have to do, raise it to the 1/2 power. So let me talk about the 5/2 getting to 10. So if I take 5/2 times 4, because then I'm going to have 20 over 2, which gets me to the 10. That's how 5/2 work. I wouldn't expect most of your problems to be that difficult in the math, if you consider that difficult. Okay, so let's get an answer here. 1.25 to the 5th negative raised to the 5/2 power, and then take the reciprocal. And I get 1.81 times 10 to the 12th. Again, I would do this on your calculator. Make sure you understand how to use your calculator properly to get the right answer. Okay, switching to a different problem. This problem is just random letters made up as an example. So I want to know Kp for this. And this is a harder question than I meant it to be. So we're going to get rid of this P part and just say that we want to know K. Otherwise, this is a much harder, more difficult problem. So I want to know K for this now when I'm given these two. So we still have to consider for each of these that same concept of forward or reverse. What do I multiply by? So the first thing we do, if you remember on these, is that we're going to label them as A and B in this case. So now we're going to talk about A and say, okay, here's my A. What in A is unique, meaning I don't see it in anything else, but I see it in my unknown. This is what I call my unknown. And I would say this is the piece that is unique right here. So that's going to be my area of focus. So I want to get that from A into the correct position of my unknown. So in order to get T2G3, it's on the same side, so I'm going to keep it forward. It's on the correct side of the reaction. And I need 2 of them, and I only have 1, so I'm going to multiply by a 2. So then I will physically do that. And if you're missing this step or skipping this step, that is possibly why you're having issues. You need to make sure you do these steps to be sure things cancel like you expect and you get the values you want. Okay, let me fix that. I accidentally erased the screen. Okay, so we kept this forward. So we want to keep the reaction written forward, but we're going to multiply by 2 the whole time. So everything gets multiplied by 2. So 4t, leave out states of matter is fine. And this is going to give us 3g2 going to 2t2 g3. Remember, when I multiply 3 halves by 2, I'm going to get 3. All right, we're going to leave the k alone for now because we want to make sure we've written everything before we try to mess with our k's. For b then. What in B is unique to B, not in A or any others, but I can see it in my unknown. I'm going to say this is the piece I'm going to focus on. So I need to get LG2 on the other side, because in B it is a product. I need it to be in my unknown or reactant, so I must reverse it to get it on the correct side. And I need 3, and I have 1 in B, and I need 3 in my unknown, so multiply by 3. So I'm going to reverse this and multiply by 3 at the same time. 3LG2 goes to 3L plus 3g2. Now, remember that things on the same side of the arrow will add up. Items that are the same on opposite sides of the arrow will reduce or cancel. So notice that my G32 is a product here and a reactant here, and they're exactly the same, so those go away. And then I have left nothing else to cancel or sum, so I have left 4t as a reactant, yes, and 3g2 as a reactant, yes, going to 2t2, 3, and 3l. So now we're set up. One of the things you might do to help you if you're struggling is rewrite once you've canceled everything to be sure it looks like you expect. It has to look like your unknown. So this, based on what I've canceled, reduced, or summed, looks just like my unknown. So now I can apply the rules of equilibrium constants that we have been working with to my k's. So then I'm going to take 1.68 times 10 to the negative fifth, and I kept it forward, so all I have to do is raise it to the 2. And then this, for part B, I reversed it, so I've got to put it underneath 1, 5.118 times 10 to the negative 7th. But we also raised it, or pardon me, we multiplied by 3, so we're going to raise it to the 3rd power, and we're going to get those numerics. Let me do that just a moment. Let me grab my calculator. So 1.68 EE to the 5 negative, and I'm going to take that to the 2nd power. So I get, for that first part A calculation, 2.82 times 10 to the negative 10th. And then for the next one, we're going to take 5.118 to the 7th negative cube it, or take it to the 3rd power, however you want to look at it. Don't forget, you may need sets of parentheses. Then take the reciprocal or the inverse, and I get 7.46 times 10 to the 18th. Okay, so then what do we do with those numbers? We take our new values of k and we multiply them. 2.82 times 10 to the negative 10th times 7.46 times 10 to the 18th. So 2.82 10 to the negative 10th times 7.46 to the 18th. And let me check that again. And I get 2.10 times 10 to the 9th as my final value of k. Okay, continuing on. Okay, this example here, we have 3, so we'll label these as A, B, and C. Probably have not given myself enough room. Okay, so what in this do we see in our unknown? I see R. I don't see R by itself anywhere else, so that's a good one. Okay, so I need R to be a reactant in my unknown, and it is in A, so I'm going to keep it forward. I need 1 R, and I have 2, so I have to multiply by 1/2. So we're going to do that it's going to be R plus 3 halves Z2 goes to R Z cubed. Remember, we're multiplying everything through by half in this case. So for B, what in B do I see that's unique to this is probably my D. So I need D to be in my unknown a reactant, and it is in B, so I'll keep it forward. I have one and need one, so I'll multiply through by 1. So D plus Z2 goes to DZ2, and then C. Let's see, what in C? Let's see, this is what we need in C. We need it to be, though, as a product, so we must reverse it. So I need it to be over here, so I had to reverse it, and I have to multiply by a half. So I will do that as I write. So RZ cubed, I'm going to do this so you can tell my Z's from my 2's. Okay, plus DZ2, multiplying by half. This will be RD plus 5 halves Z2. All right, now before I mess with my values of K, I want to be sure that things end up just like this. So I notice that I have an RZ3 as a reactant and an RZ3 as a product. So they would either reduce or in this case completely eliminate. I have a DZ2 and a DZ2 on opposite sides of the arrow. So their 1 minus 1 is 0. And then I have to deal with my Z2s. I have 3 halves Z2 and 1 on this side. So if you think about just looking at those, I have 3 halves plus 1. And on the other side, I have 5 halves. I'm looking at just my Z2s because something can be done with them because they're in more than one place. They have to be sort of summed or reduced or however you want to think about it. So if you think about 3 halves, that's not easy, but we know that we can do this based on hopefully elementary math. So we can see that this is 5 halves and 5 halves. So this and this will actually cancel with that. So what do we have left? 1R and 1D on the reactant side and a RD on the product side. So now that we know we've set this up correctly, we're going to deal with our K values. So I'm going to go down some and deal with, well, we'll just deal with the K values right here. Okay, so then we're going to take this and we're going to take this and we're going to raise it to the half power. We kept it as is because I did not reverse it, so I don't need to put it underneath 1. This is going to be as is, or you can, if you want to think about it, say you're going to take it to the first power. And then for the part C, we are going to have to do a little bit of work here. So we're going to have to take 1 over 5.127 times 10 to the negative 6. And we're going to raise that to the half power. So let's go through what those numbers will be. First number is 2.178 to the negative 10th, caret a half. And I get for this one 1.48 times 10. I'm just doing 3 sig figs to the negative 5th. Let me just check that. I always like to do that twice. Sometimes my fingers hit weird things. Okay. And then this number is going to be the same. So I'm just going to say, write that there. And then this number here, I'm going to take just a moment to erase this so it's not in our way. $5.127, 6 negative to the half power, then reciprocal. I want to check this, so just give me a moment. I want to check it. 4.42 times 10 to the second. Okay, so I get those new answers, and then I'm going to multiply them. So that number times the 3.017 times 10 to the negative 8 times 1.48 times 10 to the negative 5th. Going to multiply all those numbers up. Let's see what we get. So I got for this one 1.97 times 10 to the negative 10th. What did I do? 4.42 times 10 to the second times 3.017 times 10 to the negative 8th. times 1.48 times 10 to the negative fifth. And I got 1.97 times 10 to the negative 10. Okay, so next kind of problem here is where we have a value of K, a reaction, and it wants us to solve Kp. The relationship between K and Kp, if you recall, is Kp equals KRT delta N. Okay, so let's solve for Kp. So what do we know? Well, we don't know Kp. We know K to be 5.018 times 10 to the 22nd. R is a constant, 0.8206. Temperature must be in Kelvin. Some of you messed that up, so I'm going to go over here and say 63 plus 273.16. See what that is. 63 plus 273.16 is 336. Okay, so this is going to be 336. Now the delta N part. Remember what that is. That is the moles of gases or aqueuses. And we will assume this is a gas. This is just poorly written. So I'm going to divide this. I'm going to say there's a total 2 moles of gas on this side. And if I look at 2 plus 1, there's 3 here. Remember, this is products minus reactants. So in this case, it's going to be 2 minus 3. So this delta N will be worth a negative 1. So here's how I would do this on your calculator. 0.08206 times 336 raised to the negative 1 power. 0.08206 times 336. And then do the number in front, times 5.018 to the 22nd. So let me go through that math again. Parentheses on your calculator, 0.08206 times 336, close parentheses, caret to the negative 1, hit equals, and then 5.018 times 10 to the 22nd. And you should get 1.82 times 10 to the 21st. Okay, problem number 10. This time we're given a Kp and we're asked to calculate K. Remember that the connection between those, let me get my pen working again, is Kp equals K RT delta N. So we are given Kp this time. So K's are unknown, 0.08206 plus, convert your temperature into Kelvin, so 283, and then we're going to do our delta N here. So remember that this has 3 moles and this has 2. So then we're going to take products, 3 minus 2, so we get a 1 here. All right, so here's how I would suggest that you go through this math. I would suggest that you take 0.08206. This is multiplication, not plus. Times 283. And then raise that to the first power. So when I do that, I get 23.2. I'm just going to do 3 sig figs. So you can just keep it on your calculator. Your answer will just be slightly different than mine. Remember to multiply 0.08206 times 283, not add, multiply. So 23.1. And then we have 23.4 over here. So then we would, to solve for K, to get K by itself, I have to take both sides, divide it by 23.2. And then K equals 23.4 divided by 23.2. So K equals 1.00. If you look at chemical equilibrium homework number 1, the problems that might be helpful to review before retaking your assessment would be 2 and 3, 2A and B, 3A and B, number 4 and number 5, number 7, A, B, and C, and then numbers 12 and 13. Those would be the most useful to review before doing your retake. Please reach out to me if you're struggling with this. I can go over more examples with you.